Okay. So my name is Obaid Farooqi, which is slightly different than what people try to call me. They generally call me Obaid. So it stresses on the second syllable, Obaid. I am an escalation engineer, and I've been working with protocols quite a while at Microsoft. So today I will try to explain a little bit about SMB 3.1.1 encryption, which is coming up in the next version of Windows, and which is coming in the next version of Windows, and it is different from what Windows 8 has. So the problem you may face, since it's a new one, how would you, if you are implementing on the server side or client side and have a problem, or just plain your traffic is encrypted, you want to decrypt it, you want to see it, what is actually being sent, that problem exacerbates because our sniffers typically use session key. They have to get the session set up so that they can get the session key and all the messages and ask you for your password so that they can go and decrypt your traffic. That's not an optimal solution because every time SMB changes the encryption or session keys, you have to rewrite the decryptor, right? So to take care of that part, we developed a different package. It was not too new. It's been around for a couple of years. It's called Message Analyzer. If you haven't used it, hopefully after this presentation you will. So what is changing in SMB encryption is that we have a fixed cipher in SMB 3.0x, meaning 3.0 and 3.02. The cipher is fixed. And this is not flexible because if you want to change how the if the new cipher is available, you should be able to use it with your existing version of SMB3 without waiting for the next version to come out. So as it says, it's not flexible. And in SMB 3.1.1, ciphers are negotiated per connection. So you can definitely have different ciphers for different connections, although I don't think anybody would do that. In SMB 3.1, client can require encryption even if server does not. So this is different from the older version of SMB3. The client can actually set, I want the encryption. It was not an option in SMB3. So once you have SMB 3.1.1 going, you want to decrypt. Of course, you need to use a new version of Wireshark, which has already encrypted the decryption because encryption has changed. Or you will have to also use Netmon's new decryption somehow. Somebody has to write that. That doesn't work in this case. That is kind of inconvenience and may not be available right away. So, and also the ciphers can be added on the fly. So, I mean, it would be hard to keep up. So what do? Well, you just do not decrypt. Just don't decrypt. What you do, you capture the traffic before it is encrypted and after it's decrypted. That way you won't have to ever worry about what cipher are being used. And that is the solution Message Analyzer uses. It's called ETW Tracing. This is the only sniffer that does it. The other two popular sniffers do not use ETW tracing. Well, to be honest, Wireshark, Netmon can actually show you the ETW traces, but they will be encoded such that you will need some extra information to decode them. Message Analyzer comes built in with that information. So how do you use message analyzer? You just go to MSDN website and get it and install it on computer. But you will have to use a newer version of computer, Windows 8 or later, to use message analyzer. It is not supported on earlier Windows platforms. The other great things about ETW tracing is that you don't need message analyzer to capture the trace, which is very important. Say, for example, your customer says, I'm having this problem. You're not going to tell your customer, hey, first install message analyzer and then capture the trace, and it will be decrypted and send me the capture, right? Just too much. So you can actually use Windows command line to start capturing the traffic. The customer can just, you can just send him a couple of lines of commands in an email. They can just execute that, collect the capture the traffic, send it back to you, and you just load it in message analyzer, and it will be decrypted for you. So far, any questions? Okay, so you can get message analyzer from MSDN. Just get the latest version, please. Do not get 1.1. The current version is 1.2. Another one is on the way, which will have better parsing of SMB 3.1.1 messages, because SMB 3.1.1 has something called negotiate context in it, which is not being parsed yet in message analyzer. But as I said, message analyzer is future-proof. You don't have to have the latest version to decrypt. It still decrypts Windows 10 traffic. Today, all the Windows 10 is not out. And when you use a message analyzer, you will have to use based on where you are using it, on client or on the server. That's one thing. It's not universal. One thing doesn't do both, but not that big a disadvantage. And it does everything for you. It's really, you just select the profile, you generate the traffic, it will be decrypted, everything. You don't have to go through an extra step to enter password, and like you have to do in Wireshark, or save the traffic and then use NM decrypt like Netmon. Okay, so I guess I'm going really fast, don't I? Okay, so let me just, if people are interested, let me just show you the new pre-authentication and decryption presentation by David Cruz and Greg Kramer that they did in ISNIA, just to give you a better idea what kind of encryption changes happening in Windows 10. People are interested in that or not? Any show of hands? Okay. Just in case a little girl is shown there, that's my daughter. I'm sorry? The shirt was given by auntie. Okay, so what is happening in new version of Windows is that they are introducing something called negotiate context. The negotiate context will be added to the end of the negotiate message. And the reason for doing that is we really do not have any space left in the message itself. And the purpose of the negotiate context is to negotiate different ciphers. So that's how ciphers become dynamic. You just change the ciphers. When new ciphers are available, if your server supports it, boom, you can use it. Good thing. But what makes it difficult, what introduces a new level of security hole is a man in the middle can say, well, I am not going to send this cipher to the server because I cannot decrypt it. So it will capture the client message delete some ciphers from it, and send it to the server. And server says, of course, the client only supports these, so I will use one of them. So just to avoid that, we need to somehow do, after session setup, somehow need to figure out if there is message tampering happened since the very first message. So to take care of that, what we do is we use a different kind of pre-authentication integrity check. I am so sorry. I keep talking, and you guys are looking at my daughter's picture. Okay. Pre-authentication integrity. This pre-authentication integrity, what it does is that it takes the cipher, it takes the hash of every message before encryption has, before session setup has happened. So if you see that all the ones in the red are the ones that are unsigned, unencrypted, and in the session setup response, we are doing, what we are doing is we are taking all these messages, every single one of them. We just keep hashing them. And then in the final session setup, that hash will be calculated on both sides, and use that, we will have the keys. So the session setup response will be signed, and of course, if message is tampered, the keys will be different. Yes, yes. The next slide will explain that. So you just keep, so the hash will be different, and client or server will drop the connection based on if it is different. This, as I mentioned, the selection of the hash function is done through negotiate contexts. So here's an example how it is done. So they start with 400, and these are 4 bytes. I believe these are 4 bytes, don't take my word for it. It could be more than that. And then, as you see, as messages go, we calculate, this S means salt. So we just keep hashing it. And currently we use one hash algorithm, SHA-256, I think. And in the final session setup here, it will be signed. In SMB, even if you have not negotiated signing, the final session setup response from server is always signed. And you can check that to figure out if the message has been tampered with. Okay. Yeah, go ahead. Yes, yes, yes. It is independent of that because those authentication mechanisms are only used to calculate the session key. Okay, you use the session key with the salt to generate the signing key, application key, and encryption key. And actually the next slide explains that. So this is how you drive secret keys. You use the session key that was given to you by your authentication protocol, and then you use a label, and labels have changed in the new version of Windows. So again, one more reason to use message analyzer. And then you use these to generate the application key, signing key, client cipher key, and the encryption keys. All right, so any question on this? Okay, I guess I can go back to my presentation. This was okay. So I will actually first show you some slides where I will show you the steps how you do decryption in message analyzer, and then I will actually show you using message analyzer a decryption taking place. The reason I included some slides with pictures is so that if you ever look at this presentation again, you don't have to fire up, you don't have to imagine what I'm talking about. So you start message, and you will see the whole GUI, but important thing is for this particular scenario, you start new session and use live trace. And then, of course, it's a live trace scenario. And this is important. In the select a trace scenario, you have to select the proper scenario or you will not get the decryption. And in this case, since I'm collecting on the client side, it has to be SMB client full load. And full load is necessary because you want to see the decrypted packet, right? And then you click on start, which is pretty obvious. And once this screen is actually kind of important, and I'm sorry, I'm fading in and out. This screen is actually very important because it shows what you need to be looking at. Message analyzer is different from your everyday sniffer. So what happens that you do not get the similar Wireshark or Netmon experience. You just cannot click on a message and expect to see all the fields and everything. The most important thing, oh, sorry. Can you guys hear me? Cool. If you see on this screen, what you will see is that messages have been grouped together, okay? And that's the disadvantage of using two monitors, huh? So I have selected a message that has write request in it. Under that, you will see, it's not displayed properly here. Okay, yeah. So first line will just give you a summary, what the message is doing, what is the status, and some important fields. The second line is actually the way we are used to looking at the traditional sniffers. So click on it, and the window next to it will show you all the fields that we are used to see in a sniffer. So for example, this is the header, and then the request, and all the values of the request. And if you are interested in the binary values, then you will have to move to the third one. So as you can see, this part of the screen is giving you raw hex information. This one is giving you the traditional view of all the fields in the message, and that one is the one where you have to, if you, for example, select that under this one, this display will change. You will see different fields. So it's like you can drill down, and you can go all the way to TCP if it is TCP, but this is ETW, so the bottom one would be ETW. Okay, any question on this? There is a presentation on Message Analyzer right after this, which will be actually going through all the features of Message Analyzer. I'm only showing you one aspect of it. So if you're interested, and I hope you are, please attend that presentation too. Okay, I will handle this later. First, let me show you how we can use Message Analyzer. So this is a message analyzer trace that I took last night, and I loaded in my message analyzer, and it just dutifully decrypted the information for me. Currently, I am. If you look at the this area of the screen, I have filtered SMB 2, and now, if you look here, you'll see this message. Like for example, this is negotiate. So as I select it, here you will see different levels of it. So when I click on this, click on that, you see this display changed. Now it is showing header and request. And then you can drill down into them to see more information about what is in this message. And here. Okay, for some reason sorry. It's not the field data, it's the message data I wanted to show you. So now you have the hex and the traditional value, and over there is the trace. The other thing to note is that both request and responses are lumped together. So you don't have to go looking for where the response for this message is. All is here. And this one is a negotiate, so it's obviously decrypted. It will not be encrypted in your regular traffic. But if you go a little further here, you will notice this message. This is encrypted. And this is actually the encryption of this guy. So this is the decrypted part of this encrypted message. So you will see, if you want, you can not look at encrypted messages at all. The way I collected the trace is I collected both ETW and NDIS, which is the actual network traffic, and it is showing both of them. So that's why you will notice that I have two negotiators on top. Generally, we see two negotiators, but we are used to looking at netmon. Like netmon will show you negotiate request, negotiate response. Wireshark will show you negotiate request response. Here it is bunched together, and the reason we are seeing two of them because it captured the one from the NDIS, lower network layer, and captured one from the ETW. That's why you see the on top two messages. But here, as it starts getting encrypted, things become more reasonable, I guess. Since one is the decrypted version of the encrypted message. The decrypted one is gotten from ETW. So as you can see, my traffic is decrypted nicely, and all the messages that you want to look at, you can do further filtering on it and just take care of all the encrypted messages. Good. I'm sorry? Yeah, the way it is done is because it is captured at a much higher level. Yeah, no, loopback is just your host, and then the server address destination. Exactly, because it is hit just before it is encrypted and after it is decrypted. That's why. Right, any question on that? So to be honest, I myself did not used to use this tool because it was just a new thing to learn, and I'm very good at using netmon, so I resisted the temptation to use, resisted the need to use it. But this is a very strong case for use of message analyzer. And once you get comfortable with it, you will really like it. It provides a lot more capabilities than just this. But this is, especially Samba people, it's really close to what they do. And I was talking to one of the Samba member, and it is recently submitted the code for encryption of 3.1.1. So I guess you will be testing it, or maybe getting some bugs, and this will help you. This tool will help you to do the decryption, because no sniffer in the market can do it right now. And this is already doing it for Windows 10. How am I doing on time? I have more than 10 minutes. Awesome. Okay, so I mentioned at the beginning that you do not need message analyzer to capture message analyzer traffic, which is really a very strong point in favor of message analyzer. You don't need to even install it to capture the traffic. And the commands are built into Windows from Windows 7. So the command is net shtrace start provider. This will, as I showed you, there was a profile you need to select. There are two profiles, one for client, one for server. This one is for client. You start this command, and then you generate your traffic. And once your traffic is generated, you stop the traffic, you stop the trace, and a file will be created for you. The name of the file would be nettrace.etl. You will actually get on your command window information about where the file is on your hard drive. So just go get that file, load it into message analyzer, and it will be decrypted for you, if the traffic is encrypted, that is. To do the server, there's only one difference, and let me just highlight that difference for you. So you'll notice that this one is SMB server. The previous one was SMB client. That's the only difference. When you do it on server, you need to use server profile. If you do it on the client, you need the client profile. Stopping the trace is the same. And if you also want to capture not only the SMB decrypted traffic, if you want to capture all the traffic, you also use this command. Just replace the provider with capture equal to yes, or add capture equal to yes. I guess I need to write that down here. I hope I can. That P is really long. It's mixed case, but of course it's not mixed. You can type it anyway. Just by adding this after the command with this space, and of course in one line, sorry for my fantastic writing, you will get everything. All NDIS capture. You will also get the NDIS capture, and you can open it both in Netmon and Message Analyzer, but I would recommend Message Analyzer because that one gives you so much more. Netmon will not be able to decrypt, so you will get a lot of gibberish between your regular network packets. And of course, the command to stop is there. So as I mentioned, the advantages is that you do not need to install message analyzer. Batch file can be sent to the customers, and they can capture traffic for you and send the net, the resulting file to you. And the tool is not need to be installed. It's already there, and it can be used to capture regular network traffic. One disadvantage is that if you collect regular network traffic, you will not be able to open it in Wireshark. Wireshark does not understand ETW tracing. So, any questions? Okay, so the question is, beside decryption, is there any other feature you would like to tell about message analyzer? The next presentation will go through all of those, but some of the features that message analyzer provides you, that it automatically parses the message for you, and if there is a protocol error in it, it will flag it. So let me show you on my screen. Let me try to find an error here. So if you notice this thing here, this column is reserved for showing you something that is, of information or is wrong protocol-wise based on protocol documentation. So see, it is showing you what the problem with this message is. That's pretty neat. And also, currently we have only SMB profiles, but okay, sure. In type SMB2 packet header field is undefined value. Please refer to, I don't know, I did not look at this one before coming here. But I think probably the reason is that the message is collected, the trace is collected on Windows 10. And this version of message analyzer, while it is able to decrypt, it cannot parse for all the new information that we are adding in Windows 10. That's probably the reason, but I didn't research. Probably, that's the reason. So this is one feature which is good. It trying to suppress the noise a lot. If you look at a regular sniffer, you have to go find the message. This one tries to bunch them together and show you the errors and stuff like that. So it kind of makes your job a little easier than eyeballing the traces. The other thing is that it also can decrypt the HTTPS traffic. It uses Fiddler's technology to do that. So you basically get two in one package. You don't have to do the Fiddler if you want to do the HTTPS decryption. No. In case of HTTPS, what it does, it works as a proxy. So basically, the server sends a message, the proxy sends, the server certificate is intercepted by the proxy. And then your client, the client and proxy work as server and client. So it decrypts and then encrypts again for the client. Exactly, it does man in the middle thing. But that's how Fiddler does it, and it works that way. There are a couple more, but next presentation would give you all the features. Hopefully, most of them. I don't think she can cover all of them in this little time. Does that answer your question? Awesome. Anyone else? You have a question? We have some time? Okay, let's see. You still have 10 minutes. Come on, guys. I did not expect it to go that fast. Maybe just I start talking, I just don't take a break. You should have paused me, yeah. Stop, take a break, ask people questions. Okay, if there's no other question, then you're free to do whatever you want to do now. Oh, yeah, there's one question. Oh, yeah, I can. Okay, the next presentation would be about message analyzer. And that will be just about message analyzer, meaning how to start it, what are the features, how you can do some neat tricks with it. It's really also just to give you guys, if you are not able to get this presentation, there's a lot of material available on message analyzer on channel 9. So just go to MSDN, type channel 9, or just go there and type message analyzer, and you will get tons of presentation. And kind of those presentations are, you also show you the evolution of message analyzer, because every year in Redmond we have a presentation on message analyzer, and Paul Long, he's the presenter, he's also the program manager for message analyzer. He highlights the new feature of message analyzer, what is coming, and to parse to get rid of this error, the next release, I talked to him, so he said we have included the parsing of the new SMB features in the next release of message analyzer. But the cool thing is, you can even use an older version of message analyzer to decrypt, which is really cool. And I like it, it's future-proof. Just proof that. It's future-proof. Yes, sir. I will also repeat the question, hopefully.
Okay. So you were saying that in 3.0, the client can't request no encryption anymore, because we were using that trick. So because of this issue, if you wanted to grab a sniffer trace that was useful from our customer on our replies, we had an option in our GUI that said temporarily disable our SMB encryption on our connector. So we basically could just look at it in Wireshark and see everything, and then it would automatically turn encryption back on after, say, 10 minutes. Are you saying that if we connect to 3.0, it's just going to reject our SMB if we do that? But you've added it back in 3.1.1?
Okay, so let me answer first part of your question. Understand first part of your question. So the question Chris have is, what happens if we are actually able to decrypt the decryption and disable the encryption from the client side, right? We cannot force the encryption from the client side. That's what I was saying. So basically, in the current version of Windows, if the server doesn't want to do the encryption, the client cannot force the server to do the encryption. The later versions, client actually can force the server to do the encryption. So that's one thing. Now please repeat ask the second question.
Right, so maybe, so what I was worried about is it sounded like what we were trying to do wasn't going to work in 3.0, but it sounds like it might. But so what's the difference between 3.0 and 3.1.1 in the cipher negotiation? If I say I don't want encryption, what's the difference?
Okay, so you definitely can not use encryption in 3.1.1.2. Okay, I will have to look up the question. I will get with you after the this presentation to get your exact question, what your concern is, because this is a new version and my knowledge is not that complete. So I will have to do some research to understand really what the concern here, because currently I cannot.
Okay.
So I'll get back with you and explain and get what your concern is. Okay. Sorry, I cannot answer that part, but it's not in market yet, so not as much experience with that. Any other question? Okay. Well, thank you very much.